All right, here are solutions for perfect problem 1 from Math 60. We're basically we're multiplying, dividing, and then adding fractions. What makes it hard is these fractions are kind of a mess. They're huge numbers. But we can actually do these without a calculator if we first find the prime factorization of all the numbers that kind of make up these fractions. So I think a good first step would be to kind of create these trees for each of these four numbers up here. So 2,560, one way you could break that down is it's 256 times 10, and then 10 is 2 times 5, whereas 256, a couple different ways you can get at this. One way is just it's an even number, so it's 2 times something. And I don't know, maybe you pull out a calculator, do long division or something to find what times 2 gives you 256. The answer is 128. And if you note that 128 is even, we can say it's 2 times 64. 64, a few ways you can get at it. It's 8 times 8 is one way. And 8s are 2 times 2 times 2. So we can come up with the prime factorization of 2560 by noticing that it's 2 times 2, one of them, two of them, 3, 4, 5, 6, 7, 8, 9. It's 9 of these 2's being, what happened there? Being multiplied together. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 5. So what we now have is the prime factorization. Well, let me make dots, so we'll call that good. Of 2560. And if we continue, do that exact same thing for the other three large numbers. 9,000, you could say is 9 times 1,000. Minus 3 times 3. 1,000 is 10 times 100. But 100 is 10 times 10. And 10 is 2 times 5. So what you end up with when you finish this whole tree here is 9,000 we can get at from 3 2's, 2 to the third power, although since we haven't talked about exponents, I'll just write that as 2 times 2 times 2. 2 3's, let's show up over here, and then 3 5's. And so continuing, prime factorization of 1620. 10 times something, that something is 162. 162 is even, so it's 2 times something, in this case 81. 81 is 9 times 9. And 9 is 3 times 3. So because 10 is 2 times 5, we get the prime factorization of 1620 is 2 times 2 times 3 times 3 times 3 times 3 times 5. And lastly, you're probably getting sick of this, I know I am, 2025. Well, it ends in a 5, so it's 5 times something. I don't know, maybe the help of a calculator. To do this on the spot now. I think that's 405. 5 times 400 would be 2,000. And then 5 times 5 is 25, so we get 2,025. 405, that also ends in a 5, so it's divisible by 5. What do we got there? 81. 5 times 80 is 400. And then 5 times 1 is the extra 5. 81 is 9 times 9. The 9's, as we've seen already, are 3 times 3. So the prime factorization of 2025 is 3 times 3 times 3 times 3 times 5 times 5. 4 of these 3's, 2 of these 5's. All right. Seems like we haven't done anything. We've done a ton of work and haven't gotten anywhere, but we're actually a lot further than you might think. We can now tackle all of these problems. So 2560, we can think about that as really 9 of these 2's. I really wish I had chosen smaller numbers, both for your benefit and for mine. Is that 9 of them? 1, 2, 3, 4, 5, 6, 7, 8, 9 times 5. See, 9,000, yeah, it was 2 times 2 times 2 times 3 times 3 times 5 times 5 times 5. 1620, figured out was 2 2's, 3 3's, nope, 2 2's, 1, 2, 3, 4 3's, and a 5. All being multiplied together. and 2025 was the one with all the fives. It's 1, 2, 3, 4 threes and 2 fives. So finally, now that we have it all written, we can do the kind of satisfying part of crossing stuff out. Cancel this 2 and this 2. Cancel out this 2 and this 2. This 2 and this 2. No more 2's on the bottom, so I guess we're done there. This 5, cancel out with this 5. This 3 and this 3. This 3 and that 3. This 3 and this 3. This 3 and this 3. This 5 and this 5. I think that's everything. So what we get, maybe I'll switch back to red, is in the numerator we're left with 1, 2, 3, 4, 5, 6 2's. And then 2 more 2's over here. I believe that's it, right? We canceled everything else out. And then in the denominator, we got 2 3's and 2 5's. Which, I don't know, maybe you pull out a calculator to do this or somehow. 1, 2, 3, 4, 5, 6, 7, 8. I think you'll end up with 256 if you multiply those all together. And then this is 9, and this is 25. So 8 25's give you 200. So one more would give you 225. So what we get is that the product of these two huge numbers is this guy. We can do that same idea. 1620 we already saw was 2 times 2 times. Maybe I should switch colors. Well, no, I'll keep it in red. 2 times 2. This is 1620. You know what? I'm going to... Before I start this problem, I'm going to think about it. I don't like division. I'd rather make this a multiplication problem. 1620 over 9,000 divided by 2560 over 2025 is the same as 1620 divided by 9,000 times 2025 over 2560. What I'm getting at there is the way you divide fractions is a lot like multiplying fractions, except you got to multiply by the reciprocal, this thing flipped upside down, of the denominator. Now that I have it written like this, I can really approach it like I did part A. I know that 1620, which I already wrote up here, is 2 times 2 times 3, 3, 3, 3, 5, 9,000, 2 times 2 times 2, 3 times 3, 5 times 5 times 5. And then I want to multiply that thing by 2025, which is what I had in the denominator here. So that's 3, 3, 3, 3, 5, 5. Divided by 2560, which is what I had on the top up here. That's the one with all the 2's. 1, 2, 3, 4, 5, 6, 7, 8, 9 of those 2's and a 5. 2, 3, 4, 5, 6, 7, 8, 9, and a 5. Okay, now the satisfying step of canceling stuff out. 2's, 2's, 3's, 3's, 5. Is that all I can do? No, I got another 5. Another 5. So I'm left with only 3's up in the top here, but I have no 3's left in the bottom. So I guess that's all I got. Maybe I should write it out. 1, 2, 3, 4, 5, 6. 3 times 3 times 3. Then the denominator, I got a 2 here, and then the 9 that I had over here, so that's 10 2's and a 5. Or 9 here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 of these 2's. And a 5. Wow. All right, that's going to be a mess. At this point, you might want to just throw this into a calculator. See, this is 9 times 9 times 9. 9 times 9 is 81. Times 9 again is 729. But I wouldn't want you don't have to do that in your head. You can just throw it into a calculator. 2 times 2 times 2 times 2, 10 times is 1,024. Multiply that by 5. Man, this is a lot for me to do in my head. So what did I say? It was 1,024 times 5. That's 5,000. And then 24 times 5. Well, 20 times 5 is 100. So 5,100. And then 4 times 5 is 20. It's 5120. I'll erase that and write that here. And I now have my answer. Then finally, this last one, we'll start it out the same way. Well, actually, now that we're adding fractions, we don't really need to find the prime factorization for the numerator, even though we already have it. What we could do is just find the prime factorization of the denominator. So 2560, that was the one that was kind of obnoxious with all the 2's. It was 9 2's and a 5. And then we want to add to that 1/2. Note the prime factorization of 2 is just 2, so that's already done. The least common denominator of 2560 and 2. So you're looking for a set of numbers that contain all these numbers and this 2. Well, it's actually just this 2560, because 2560 goes into 2560 and 2 goes into 2560. So really what we could say is we got 9,000 divided by this 2560 plus, in order to make this denominator equal to 2560, we'd have to multiply the top and the bottom by 1280. What we now have is a least common denominator. We got 9,000 of these 2560s plus 1280 of these 2560ths. Since we have a common denominator, we can just add the numerators. 9,000 plus 1,000 more is 10,280 divided by 2560. And I guess we should reduce that fraction. Yuck, I don't really want to do that, but I guess we should. In order to do that, I need the prime factorization of 10 to 80. Well, it's something times 10. 1028 times 10. I know 10 is 2 times 5. 1028, that's an even number. So that'll help a little bit. It's 2 times something. In this case, that something is 514. Still even, so it's 2 times something. In this case, 257. 257. Geez, hope that's prime. Yeah, it's not even. If you add them up, it's not divisible by 3. It's not divisible by 5. You can just check to make sure 7 doesn't work. If you keep trying numbers, I don't think you'll find anything. I think 257 is prime. I might say you don't have to reduce this answer. I might tell you in class that this is a perfectly good answer. But I'm going to finish it anyways as long as I'm here. I have the prime factorization of this 10,280 here. It's 2 times 2 times 2 times 5 for this 5 times 257. And then in the denominator, this 2560, I already have that prime factorization. It's all the 2's, 9 of them. And a 5. So I can reduce now. I can cancel out this 2 and this 2, this 2 and this 2, this 2 and this 2, this 5 and this 5. And what I'm left with for my final answer is just the 257 in the numerator. And in the denominator, 2 times 2 is 4, times 2 is 8, 16, 32, 64. 257 over 64. What a mess. If those make sense to you, if those methods make sense, that's great. Know that on quizzes I'd never give you numbers this hard or this tedious. But I guess that's the end of this solution.